Hello and good afternoon. My name is Michael Whaling, and today we will be doing the interactive advanced concept presentation 2, where I will be making a DIY lava lamp using some water and a water bottle. I have olive oil here. It does say vegetable oil, but we're going to see if olive oil works. And Alka-Seltzer. On top of it today, I decided to go with blue coloring dye, and we're just going to see how that works out today. So, water is a polar molecule, and oil is a non-polar molecule. So they won't mix because their differences make them insoluble, meaning that they do not, they're not soluble. They do not mix together. So when I pour the oil in, you will see a clear layer of the oil and a clear layer of the water. So let's do that first. A little scared of spilling the whole thing. Oh man, this one's not even open yet. Whoops. Okay. Fresh olive oil. Okay, that should be fine. Let's do it again. There we go. So if you see here, the oil is not mixing with the water and instead making its own layer above the water. Because water and oil are insoluble. Kind of wish I did have vegetable oil because I know it's more clear. Probably would have better results. Alrighty. That's a lot of olive oil. That's alright. All for the means of science. That's the wrong cap. So let's put the oil away for a second. So if you get a real close look up here, you can see two distinct layers. And no matter how much you try to do this, there's always going to be different layers. So, vegetable oil and olive oil do have the same properties. Since water is more stable than oil, it's going to have a higher surface tension, putting it at the bottom, whereas oil is not as stable, putting it above. The more stable one's going to be at the bottom, then the layer above it goes on top. These two are going to repel each other. So, again, they're not going to mix because they're insoluble. And then they tell to add a couple drops of food coloring. Let's add 10 drops. Not coming out. Can I take off the whole thing? Oh man, let me pause. Alrighty, we're back. So, it's gonna be 10 drops of this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go for 12. 11, 12. Okay. So as you can see, this is a pretty fascinating part. So they're going to be floating on top of the olive oil, but would eventually, with a little bit of help, will permeate to the bottom. Or not. But we will now add the Alka-Seltzer to our DIY lava lamp. Have it fall over. The guide recommended 3 tablets for the most bubbles, so I'm going to get 3 right here. It's going to be a lot to clean up after. Alright, so let's add these tablets see what happens. Okay. It's bubbling. Let's see if I can try to get the light darker. And I had a little idea of doing this on top of it. We're going to get the flashlight here. And put it on top. Look at that. Our own little DIY lava lamp. It's a kind of orangish color. I like it. We used red food coloring, but I think the mixture with the what's it called? The olive oil instead of the vegetable oil would really change the color. So let's get a closer look on that. It looks really good. I'm really happy about that. Wait. Yeah, look at that. That is so cool. So let's get more into the science aspect real quick. So, water has hydrogen bonds, and these bonds are some of the strongest bonds, which is why the oil will not mix or break the bond. And water is an octet, which is, this is because the central atom, hydrogen, fills the octet rule. And when Alka-Seltzer is reacting with the aqueous mixture, it causes it to bubble. So you could call the Alka-Seltzer the reactant. And the reason why it stops, because the Alka-Seltzer is the rate limiting reactant. It stops when the reactant runs out and is completely mixed with the mixture. So as you can see, it's starting to kind of fizzle out right now. The Alka-Seltzer has completely mixed with the water. But simply, if you just get more reactant, and you break it in pieces, you now add more reactant to your solution, and when it reaches the bottom, past the oil, it simply starts bubbling again. I dropped one piece, let's put it back in. So, again, does not react with the oil, but then when it hits the water, it does react, causing it to bubble again, as you can see in the video. And that's the whole experiment. Thank you so much for watching. Until next week.